Good morning, children. Today we are going to do chapter 7 of maths, cube and cube roots. Cube means multiplying a number with itself 3 times. For example, 1 multiplied with 1 multiplied with 1. Same number multiplied with itself 3 times is written as 1 raised to power 3, or it is read as 1 cube. Its value is 1. 2, when it's multiplied with itself 3 times, it is read as 2 cube, and the value of 2 cube is 8. So similarly, we find the cube. Suppose 7 multiplied with 7 multiplied with 7. So this can be written as 7 cube, and its value, if you multiply, you will find it to be 343. So 7 cube is 343. So this 343 is the cube of 7. 8 is the cube of 2. Okay? And this is how a cube is written. Now, cube root is opposite of cube. This symbol you have learnt earlier is the symbol of square root, and if you write here 3, then it is the symbol of cube root. Suppose I write here 8 inside this, then it is read as cube root of 8. And you know, 8 is the cube of 2, so cube root of 8 is 2. So as it was in square and square roots, same way in cube and cube roots. 2 is the cube root of 8 and 8 is the cube of 2. Similarly, 343. 343, it is the cube of 7, and cube root of 343, remember to write 3 here, cube root of 343 is 7. 7, if you find its cube, you will get 343, and cube root of 343 is 7. Here we have tables showing cubes of numbers from 1 to 10 and then from numbers from 11 to 20. You should learn the cubes of these numbers from 1 to 20 by heart. In this first table, if you complete the table, you will find that 10 cube is 1000. So from 1 to 1000, there are only 10 numbers which are perfect cubes. They are perfect cubes because they are cubes of natural numbers. The second table shows you the cubes of numbers from 11 to 20. And if you see both the tables, you can easily make out that from 1 to 8000, there are only 20 numbers which are perfect cubes. Another important thing to remember is that cubes of even numbers are always even. Similarly, for an odd number, its cube also will be an odd number. Let's see an interesting pattern in the number and its cubes. 2, 3, 7 and 8. Remember these numbers. We had some specific feature for these numbers in squares as well. And here also, in cubes also, we have some specific features. So for 1, the cube has 1 at its units place. For 4, it is 4. For 5, units digit of cube is also 5. For 6, it is 6. For 9, it is 9. And for 10, that is the last digit is 0. So here also the last digit is 0. But for numbers 2, 3, 7 and 8, it is different. For 2, the last digit of the cube is 8. And for 8, the last digit is 2. A similar pattern for 3. Any number which is having 3 at the end, its cube will always have 7 at its end. Similarly, a number which has 7 at its end, its cube will always have 3 at its end. Let's see the other table. Here we have the table from numbers 11 to 20. So here also for 1, the last digit is 1. For 4, the last digit is 4. Same is for 5. For 6 also the last digits are same. For 9 also, and for 0 also. Where does it change? For 2 and 3. For 7 and 8. Now what is the last digit? The last digit here is 2. For the cube, the last digit will be 8. Similarly, for the number, if the last digit is 8, its cube will have last digit 2. Same is for 3. 3 A number ending in 3, its cube will have last digit 7, and the number ending in 7, its last digit in the cube will be 3. So remember this. For 2 it is 8, for 8 it is 2, for 3 it is 7, and for 7 it is 3. For rest of the numbers, whatever is the units digit, same will be the units digit in the cube. So now look here, try these questions from page number 111 of your textbook. What you have to do here is find ones digit of the cube of each of the following. That is units digit of the cube. You have to just find the units digit of this big number's cube. So if here last digit is 1, its cube will also have last digit or units digit as 1. For 8, you remember it changes to 2. So for this number, if you find its cube, its units digit will be the units digit of the cube will have 2. For 9, the units digit will be 9 in its cube. For 4, the units digit will remain 4 in its cube. For 7, it changes. If you remember, for 7 it is 3. So the cube of 77 will have last digit as 3. For last digit 2 here, the units digit of the cube will be 8. If you remember, 2 will have 8, 8 will have 2, 3 will have 7, and 7 will have 3. So that's what we have to do here. Let's see some more interesting patterns for cubes. 1 is an odd number, 3 and 5 are odd numbers, 7, 9, 11, they are all odd numbers. All the numbers which you see here, they are all odd numbers. Let's see the second example first. 3 and 5, they are consecutive odd numbers, they come one after the other. How many odd numbers are here? Only 2. And 3 plus 5 when we do, we get 8, and 8 is cube of 2. 2 cube because we added 2 consecutive odd numbers. See this one. 7, 9 and 11 are 3 odd numbers, and they are also consecutive. They come one after the other. And their sum is 27. 27 is 3 cube. How many odd numbers? 3 odd numbers. So we get 3 cube as the answer. Here we have 4 consecutive odd numbers. So the answer is 64, which is 4 cube. Here we have 5 odd numbers. The sum is 125, and 125 is 5 cube. We get the cube of the number we add. 5 digits we added, 5 odd numbers we added. So we get 5 cube. So this is an interesting pattern. And here one question for you is, how many consecutive odd numbers will be needed to obtain the sum of 10 cube? 10 consecutive odd numbers will be needed to get 10 cube. 10 cube is 1000, so you need 10 consecutive odd numbers. But which consecutive odd numbers, that you need to find out. Also, see that if 1 is used here, then for 2 cube, the next 2 numbers are used, 3 and 5. 5 is used here, now the next 3 numbers, 7, 9 and 11 are used. So suppose you need to find out 6 cube, so you will start with which number? You will start with 31. 31 plus 33 plus 35 plus 37 and so on. And because you are finding 6 cube, how many numbers will you add? Only 6 consecutive odd numbers. And you will start from 31. So try to make the pattern up to 10 cube in your notebook. So try this from page number 111 of your textbook. You have to find 6 cube in the same way as it is shown here, then 8 cube, 7 cube. So try to do this. Now there is another interesting pattern. Here they are finding the difference of 2 consecutive numbers. 2 and 1, they are consecutive numbers. 3 and 2 are consecutive, 4 and 3 are consecutive. Similarly, given you in the exercise are 7 and 6. So they are also consecutive, 12 and 11, 20 and 19. Okay, and so on, 51 and 50. Now, there is a pattern to find the difference of the cubes. You have to find the cube of 2 and 1. Its difference. 4 cube minus 3 cube. It's easy. See the pattern. The first number is 1 in all the 3 plus. All the three have same sign. Then this number is the number which is here. 2, 3, 4. So here also 2, 3, 4. If it is 3, it is 3. If it is 4, it is 4. Okay. Now see the next set of numbers. These numbers are written here. 1, because here it is 1. So the first digit is 1, then plus 2 minus 1. So here 2 multiplied with 1. And then it is multiplied with 3. See, in all the 3 it is multiplied with 3. So let's just see 1. What you see here is, first you have to write 1 plus 4 and 3 are the numbers, so you'll write 4 multiplied with 3 and then you will multiply it with 3. Let's see here. Now using this pattern, let's try to solve or find the answer to 20 cube minus 19 cube. So we will use the pattern which is given here. The first number is 20. So 20 cube minus 19 cube. The first number written is 1. Then the given number, the next number, and then multiplied with 3. So we'll write it in the same way. First we'll write 1 plus our first number is 20. So we will write 20 multiplied with the next number, that is 19. And this whole thing we will multiply with 3. Now this is multiplication. Okay, as per BODMAS rule, we need to solve this first. Now 20 multiplied with 19 multiplied with 3 gives us 1140. So 1 plus 1140, the answer is 1141. That is 1141. So when you subtract these two numbers, your answer is this. Okay, let's check it. You know 20 cube is 8000 and 19 cube is 6859. And when you subtract these two, you will get 1141. So instead of finding the cubes, you can directly use this method. It is a simple method. Multiply these two numbers, multiply it with 3, like 20 multiplied with 19 multiplied with this 3, one of this, and then add 1 to it, and you will get your answer. Okay, let's see one more example. Suppose you have to find 12 cube minus 11 cube. So what you will do, you will multiply 12 and 11 and 3, and whatever answer you get, you will add 1 to it. Okay, so 12 multiplied with 11 multiplied with 3, when you add 1 to it, you will get the difference of these two numbers. In the previous chapters, you have already learned how to find the prime factors of a given number. Here you can see the prime factors of 216. Now for a number to be a perfect cube, the prime factor should be in group of 3's. You can see here there are 3 2's and there are 3 3's. If they are in the set of 3's, then the given number is a perfect cube. So we can say 216 is a perfect cube. Let's see one more example. Let's see this example. Here, for this number, if we factorize, these are the factors. These are the prime factors of this number 68,600. Now you can see here there are only 3 times 2. 5 is only 2 times, but 7 is 3 times. Okay, so this 7, they make a group of 3. This 2 makes a group of 3, but this 5 is not having a third partner. So this number 68,600 is not a perfect cube. When we write it, when we write the factors of this number, we will write like this. It is 2, how many times? 3 times. So 2 cube. But 5 is only 2 times. And 7 is 3 times. So because there is 1 5 less, this given number is not a perfect cube. If we had one more 5, then it would have been a perfect cube. So there is a question in your textbook. If the given number is not a perfect cube, then with which number it should be multiplied to make it a perfect cube? So suppose I multiply it with 5. This side also I have to multiply with 5 and the number will change. I'll get a different number. But then that number will have 3 2s, 3 7s and 5 also will be 3 because I have put one extra 5. So to make 68,600 a perfect cube, with which number should I multiply? I should multiply it with 5. So if I multiply the given number with 5, I will get a new number 343,000 and its factors will be 2 cube, 5 cube and 7 cube. So each one is a cube, each of its factor is a cube, so the given number is a perfect cube. And we can write like this: the base numbers, that is 2, 5, 7, all this we will write down in one bracket and put that cube outside. All the 3 cubes will put outside the bracket. Okay. Suppose same number I have to make it a perfect cube by dividing it. So which number should be removed? This 5 square only should be removed, and 5 square is 25. So while multiplying, I have to multiply the given number with 5 to make it a perfect cube. But while dividing, I have to remove this whole set of number, which is not helping it to make it a perfect cube. So I have to divide by 25. You have these type of questions in your textbook. Now we will see how to find the cube root of a given number. There are two methods. One is prime factorization method and the other one is estimation method. But estimation method is used only if that given number is a perfect cube. Otherwise, same answer you will get for many numbers. Let's see one example of finding the cube root using prime factorization method. Now here we have the factors of a number 13,824. Let's see how to find its cube root. So first what you have to do, you have to find all its prime factors and put them in groups of 3s. See here, 2, 2 and 2, 3 times, then another 3, then one more set of 3 numbers and then this set of 3 numbers. So all these factors of this given number, our number is 13824. Okay, so all these factors, either you write in one line how many times you have 2, you count and you have to write here, and then you have to make a set of 3 numbers together. Put them in groups of 3s. This is 3 numbers, this is another set of 3 numbers here and here. Now let's put them in the form of cubes. So I can write it as 2 cube, another set of 2 cube, one more set of 2 cubes. See, this 3 as 2 cube, these 3 as 2 cube, these 3 also as 2 cube, and then last set of number here 3 cube. All this I'll put the base numbers in the bracket and put a cube outside the bracket. Okay. And now the next step is to find the cube root of this number. We have already discussed the symbol of cube root. This is 13824, should be under this cube root sign. And now we will write only these numbers. This cube and the cube root, they cancel each other, remember, as it was in square. So what is left now? Only the base numbers. Okay, now we will not write cube anymore, and if you multiply these numbers you get 24. So 13,824 is the cube of 24, or 24 is its cube root. This is how we find the cube root of a given number. This is prime factorization method. Now let's try to find out the cube root of this given number using estimation method. But remember, estimation method is just to estimate the answer, and sometimes if the number is not a perfect cube, you will get a wrong estimation. First, what we have to do is we have to divide the number in set of threes, like 3 digits in one group, then the remaining digits in another group. If there is one more digit, that will be going to third group. So 3 numbers in a group. So this is our first group. On the right hand side, this is another set of group of numbers on the left hand side. Now this number is only used to find out the units digit. You remember the table. If 1 is a units digit of a cube, its cube root will also have 1 in its unit digit. So here the units digit is 2. So if you remember, where do we get 2 in units digit, or what will be the units digit of its cube root? It will be 8. Because for 2 it is 8, for 8 it is 2. You can refer the table again in case you forgot. Now this number is used to find out the tens digit. So these 3 digits are only used for estimating the units digit. Now coming to this number, it's 110. 110 lies in between which two perfect cubes? 1 is a perfect cube, then 8 is the next perfect cube, then 27, that is 3 cube is 27, 4 cube is 64, 5 cube is 125. So our number lies in between 4 cube, which is 64, and 5 cube, which is 125. Our number 110 lies in between 4 cube and 5 cube. Now out of 4 and 5, 4 is the smaller number, so that number we will take. So units digit we got was 8 and tens digit is this smaller number 4. So 48 is the cube root of the given number. So we can write it using estimation method. The cube root of 110,592 is 48. This is how we estimate the answer. But remember, instead of 110, if it was 115 or 120, or here also if it was instead of 59 it was 65 or any other number, then too we would have got this 48 as its cube root. So estimation method is just to estimate the answer.